Today we will talk about AI and sleep. And I just wanted to introduce us so you know a little bit why we decided, me and Tina, to organize this session.
Hello, good morning everybody. It's my pleasure to welcome you today to the session on AI and sleep. And also it's my pleasure to introduce Dr. Francesca Faraci, my co-organizer for this session. Francesca Faraci is the founder and also the leader of the Biomedical Signal Processing Group at SUPSI, the Institute for Digital Technologies for Personalized Healthcare in Ticino. And she did a laurea in physics and a PhD in electronics, and after that a postdoc at the University of Coimbra in Portugal and also at ETH in Zurich. And she started her research group in SUPSI in 2009. And her research is using artificial intelligence and computational modeling also to study clinical signals, and she has a very interesting mixture of research and also a lot of industrial outreach and collaborations. And she's involved in a lot of European projects, and her research broadly studies in 3 axes: the brain, so brain studying, analyzing brain signals and the relation to sleep; the heart, and having AI techniques to study rare heart disease; and also lifestyle for monitoring, for example, the behavioral state of individuals to support lifestyle changes.
Okay, thanks a lot, Tina. Yes, instead of Tina, she is associate professor, assistant professor at the University of Bern, and she got a diploma in electrical and computer engineering at the National Technical University of Athens in Greece, and then she got a PhD in neuroscience at the University of Lausanne, so she is kind of coming back in these days. And then she got a postdoc at the University of Zurich and in California, at the University of California. And since 2019, she's at the University of Bern. And she is the founder and leader of the Cognitive Computational Neuroscience group at the University of Bern. And her focus are on sleep disorders, so that's how we met. And the group she's leading, they are developing some tools for EEG analysis. And she's also focused on coma, so she's looking for predictors of the coma outcome, and on perception and cognition. Try to understand how does the brain process stimuli from the environment. So this is us, and we have a strict collaboration on many projects related to sleep. Let's say that I work more with the industries and she works more with academia, but we collaborate a lot together. And today we organized together this track. Your turn.
So why are we here today, and why are we actually interested in sleep? So why is sleep so important? We all spend about 1/3 of our lives sleeping. This is a very integral part of our lives. Sleep is very essential for our health and well-being. Try to get some work done after a night without sleep, and you can figure out yourselves how important that is. And we actually know today that sleep is far from being a very passive state. Our brain is very active, our body is very active during sleep, and we have a lot of different signals that we can record and analyze in individuals that sleep. And sleep is also very important for supporting cognition, so it has huge benefits in learning, in memory consolidation, and just helping us cope better with the world around us. And very last is also very important for supporting generally immune function and recovery from different disorders. And sleep is also a very fragile state because apart from positive benefits, the lack of sleep or bad sleep can result in increased chronic health conditions. So for example, cardiovascular disease, psychiatric disease, epilepsy, all of these are very strongly coupled and have bidirectional links with sleep. And also a bad night of sleep can lead us in impaired cognitive function, impaired memory, and mood disturbances, and overall a very decreased quality of life. So it's very important for us to understand sleep and study sleep and have the right tools and technologies to assist in improving our sleep and also improving sleep in patients that have troubles with that. And sleep can also actually, unfortunately, go wrong. So we have a very large spectrum of sleep-wake disorders. You can see here a few of those, and you will hear more about those also in the next talks. And these are actually quite prevalent. So about 9 out of 10 of us will at some point have troubles with sleep, not necessarily qualifying for a sleep disorder, but troubles falling asleep or feeling refreshed after sleep, for example. And all of these have a huge impact on health. They can be linked with cardiovascular, psychiatric disorders, and comorbidities. They have a huge impact on economy. So it's about treatment costs, reduced productivity at work, absence from work, and they overall deteriorate quality of life. So they result in daytime fatigue, in cognitive impairments, and also increase accidents, for example, or injuries. So understanding sleep disorders is very, very important to be able to treat and diagnose them. But today, in the field of medicine, we have a problem of poor diagnostic criteria, a lack of objective biomarkers for sleep disorders or for several of the sleep disorders, and also suboptimal treatments. So these are all topics that we will be touching upon with our speakers later on.
Okay, so it's my turn again. Okay, so we are researchers, so the first question that we ask ourselves is, I want to know better sleep, how to measure sleep. And actually there are many different ways of measuring sleep. Let's say that the best one is the full polysomnography. And if you have really a bad problem sleeping, they ask you to sleep one night in the hospital with a lot of electrodes attached to yourself. The main one are the EEG, the EOG, the EMG, and the EMG chin. And believe me, you can sleep with all this stuff. People manage, so everyone can. And these measurements can really give very good, accurate measurements, but they can be a little difficult to use at home. And they are trying, and they manage to monitorize them with the portable EEG home, but still there is some trouble that needs to be solved. In the wild, we find really several more ways of measuring sleep. There are wearables, nearables, and airables also around. Let's say that on the right you see the wearables, the stuff that you can put on your body, and the main one and the more known one are the Oura rings or other rings that are coming out on the market. The smart bands like the Hoop, and is very nice because you don't have the screen on the watch, so you are not tempted to spend some time looking at the screen instead of sleeping. And then we have other devices like the Garmin or the Fitbit or many other smartwatches that can give you some information about the quality of sleep. And we will see more about these in other talks. Then we have the nearables, that are devices that you put close to your body or under the mattress, like the one from Withings, or close to the pillows. And these can use the accelerometer data or other data coming from radars to track your sleep. Then you have the last one that are some hubs. They use Wi-Fi or other frequency waves to track the movements. So they are the less invasive ones, we can say, but they are also, they are a little bit less accurate, but they can give some information about sleeps. So we have plenty of devices. Some are medical certified, some are not, but they all can give some information about sleep. So that's where everything starts, from the human being. If we have a problem with sleep, we want to get it measured, to get clarity about our problems. So we go to the hospital, to the clinic, and they can start to do measurements. Once that there is some data to play around, AI can intervene. And how can AI help? Well, AI can help in all the steps. It can help at the beginning when there are measurements ongoing, so improving the quality of the data. Can help during the usual steps of pre-processing, feature extraction, and the curation of the data. And then AI can create some modeling that can be used for identify early markers or some prediction of possible disease and disorders. And then, of course, you have to come back to the clinic. You have to close the cycle if you wanted to validate the instruments that you're using, the model that you're using. You have to close the cycle and go back in the clinic. Okay, so in summary, how can AI help? Okay. We saw it's the basic help that it can be given is to improve the quality of the data, so to improve the measurements, like missing data and so on. Then AI can be used for evaluation, so to understand better the data and to have some automatic evaluation of the data that is collected. But it can also be used to improve sleep. There are now several mobile applications that are used to really help us, mindfulness, to have a better quality of life, to sleep better. And they are really becoming our companion. And the last one, they can help, of course, to improve diagnosis of sleep and wake disorders.